So on Tuesday we had discussed two sample problems. One of them is to determine the moments given the moment's arm and the tension or the force. Of course, and this is quite direct, and because the quantity to be determined is the moment. So the thing you need to do is to write down your moment's arm and then your force, and last you will get the moment. And the second, this is the first sample problem, and you can take a look. You can read it on YouTube video if you want to copy this. And for the second problem is a bit different. In the second problem, we know the moments about O. We know the x, y, and z components of the moments about O, but we don't know everything about R and P. So I think there is a question in this week's homework with this similar with a similar format. Now, what you need to write is the same. So first of all, write down M equals to R plus F, and then the key point in dealing with difficult problem is you need to know what is known and what are unknowns. Okay, sometimes if you face a difficult problem and sometimes you forget what to do. The first thing is to separate the known things and the not unknown things, and then you write down the moment's arm and the force. Now, and so we get these three equations, and from equations 2 and 3 you will know P and phi, and then after you know P and phi, and then you can get theta. And there's a little trick here that there are two values for phi, and only one of them is the one we want. It's okay. These are the things we did on Tuesday. Now today we will work on the next page, scalar product or dot product, and I think you have also learned this at high school, and this is in Chinese. This is this one. Now, and we have two vectors, and we want to multiply them. Now, in this dot product, the product of these two vectors is a scalar. Suppose we have these two vectors, and the angle between them is theta. Now P dot Q will give a scalar with magnitude of PQ cosine theta. It's okay. I think have you learned this at high school? If yes, then please raise your hand. Yeah, very good. So I will have a quick. I'll go through it quickly. Now, and these properties, I think you should know them. And P dot Q is equal to Q dot P. If P and Q can be written in PXI plus PYJ plus PZK, then P dot Q is equal to this one. If we do carry out the dot product by itself, and we will get the square of the magnitude of the vector itself. Okay. Now, and we have two applications. We have two uses for these dot products. The first thing is to determine the angle theta in this problem. Of course, we can use cosine rule or sine rule, this type of thing. That of course at high school you know this kind of thing, right? Or this type of things. But the easiest thing, especially when you write when we write computer programs, is to determine the theta, the angle theta by this format. And by putting PQ to the left hand side, we have this one, right? This one is cosine theta is equal to P dot Q over PQ. Now, P itself is the square root of P dot P because of this one. And Q itself equals to the square root of Q dot Q. So we usually determine cosine theta or theta using this format because it is easier to write computer programs using this form. And this sometimes it is difficult to write in this form because you need to determine which side. Because we have, for example, we have a triangle. We need to form a triangle, and we need to determine which one is A, which one is B, which one is C, and which one is theta. Sometimes we will mix things up, and therefore it is easier to do it this way. So this is the equation 3.32. You need to and you need to use this in homework. This is the first use or the first application of dot product. Now, and the second thing is we call projection. It is similar to what we did on 3D to 2D. 3D to 2D drawing. And sorry. So what do we want to do here? We have a vector P. We have a vector P here, and we have a line here, OA. Suppose we want, and if we look at the problem from this side, and if we look at the problem from this side, what do we have? We have a line OA, and because the directions of P and OA are different, because the directions of P and OA are different, so the vector P will be like this one, right? They will not overlap on the same line. There is always an angle here, right? There's always an angle between P and OA. We want to determine one thing. We want to determine this length. We want to determine this length, which is the components of P along OA. We call it P parallel. Of course, in this graph, it is this way. If the angle between OA and P is theta, now P parallel is equal to P cosine theta. Is that okay? Now we want to determine this quantity, and the method to determine this is we use the we assume OL equals to Q. The length of the length of OA. Sorry, I should OA. The length of OA is equal to Q. It can be of any length. It can be it does not need to be equal to 1. It can be of anything. It can be short or it can be long. But the key point is we want to get the direction. We want to get this direction. Okay. Now, and we begin from here. P dot Q equals to PQ cosine theta, and P parallel, because it is equal to P cosine theta, therefore it is equal to, we put Q to the left. So we have this one. We have this thing. Because we are simply putting Q to the left. And now we go on with this is one fraction. This is one fraction, but we want to rearrange this fraction. Sorry. We want to rearrange this fraction to become this form. We want to rearrange it into this form. Now, this one, and for this thing, you should be familiar with this, that it is on page I think 15, and page 15. This has because the original, the magnitude of Q as a vector is Q, and divided by Q, and the magnitude of this fraction is equal to 1. It's okay. Because the numerator is the one above, numerator has the magnitude of Q, and the denominator, the one below, has the magnitude of Q as well. Therefore, we have the magnitude of this fraction is equal to 1. Therefore, this is a unit vector. So this is to determine the projection. P parallel is equal to P dot the unit vector in the direction of OA. So this is lambda OA. Let me make it bigger. It's okay. We will use this in a minute. We will use this in a minute, and but does it look logical? So there's some logic behind this. I will come back to this part towards the end of the lecture. Take your time to write this down, and I will go to the next page. After you have copied this. Okay, so and I will come to the next page. Now, and it seems that who has read the textbook on this topic? Can you raise your hand? Oh. I can't see any yet. So we come to so I will talk about this, and please, if you have any problem, you can take a look of the textbook. Now, this is a shaft. This is a shaft, and in mechanics, and shaft means it will rotate. About OA. O is here, and sorry, OC. I think I should write it as OC. And in the following 5 minutes, I will use this notation. This one is force, and this one with double arrow. Means moments vector. It's okay. In the force or moments arm, the single arrow means force or moments arm, and the double arrow means moment vector. In the future, you will know this type of line means the center. This is what called center line, and it marks the center of rotation. In the next semester in engineering drawing 工程图学, you will know this means the center of rotation. Now, and let's consider two forces. The first force is like this. It is it goes from point it acts on point D, and it goes like, I should put it like this. This is force F, and it is let me make it magnify this, and it's easier for me to draw. And this one is with right angle, and this one is with right angle. This moment's arm is R. Let's say R1. This one is F1. So this force is going from here, and if we have the force is perpendicular to the radius of the circle. So suppose we have the force goes like, the force goes like this way, in this direction. Okay, so it will lead to rotation of the shaft, right? If the force goes from, if the center of rotation, if the center axis, the center of rotation is here, and then the force is here, then it will lead to rotation of the shaft, right? Now we go, let's consider another force. It is at point A. And the force is going in this direction along the axis. Oops. This it acts on points B. It acts on point B, and the direction is direction of F2 is parallel to OC. Okay, F2 is parallel to OC. Now it means if this is the shaft, it means the force go in this direction. Okay, if this is the shaft, and it means the force go in this direction. So would the shaft rotate? No, right? Because only for F1 it goes in this direction, so the force will the shaft will rotate, and but if the force goes in this direction along the direction of OC, then it will not rotate. Is that clear? So first of all, can you imagine that this will lead to rotation because it goes like this, and the F2 is along the axis of OC, and therefore it will not lead to rotation. I think this is clear. The physics is clear. The next point is how do we make it in a mathematical sense? How should we put this into mathematics? The next thing is how should we put this into mathematics? Now, and how do we determine moments in mathematics? M is equal to what times what? What cross what? M is equal to R cross M. Okay, R cross M, and in the direction sense that we follow the right hand rule, right? And if R is in this direction and F is in this direction, that the moment is in this direction, and we raise the moments vector in the direction of my thumb. This is M. I would say MC. Just in case you and we write it in a double arrow pointing at the direction of thumb. I think it sounds logical, right? If you are okay with MC, let's do. You can think about. We can think about how should we do it on the F2. How should we how should we draw the moment vector in the for this group? Because R2 is pointed upwards and F2 pointed to the left, so the direction of rotation is this one. Therefore, the moment's arrow will be pointing out from away from the shaft. This is our MA. Right, this is if you want to mark it down, is R2 cross F2. This is MC equals to R1 cross F1. Is that? At least can you understand my drawing? So this one is going this way, and this one is going this way. Now, so what can we draw? What conclusion? What conclusion can we draw from here? Conclusion is oops, sorry. The conclusion is that if this force and this moment arm will lead to rotation, and we can see that MC is parallel to OC. MC is parallel to the line OC. And in the second case, it does not need to rotation. And if we look at the moments vector, it is MA is perpendicular to OC. It's okay. It means for any force that goes from here or goes in this direction or goes in this direction or in the other directions, we can see we can check if this will lead to rotation by looking at whether if this moment vector is parallel to the axis, parallel to this center line, or whether this is perpendicular to the center line, or how much of it is parallel and how much of it is perpendicular. So to determine this, and let's look at the angle between M and OC. So this one is 0 degrees and this one is 90 degrees, right? And by using dot products, we can say MC dot lambda OC is equal to MC, and this one is MA dot lambda OC, because these two are perpendicular. Cosine theta equal to 0. This one is equal to 0. So I should make it towards. Is that does it sound logical? So because these mathematics, these are all these figures and physics and mathematics and dot products determine how much the force will rotate in the axis OC. So we have we define a term called FOC. This one is called let me first let me write it down, and I will stop here after I write it down.